Methods Part 2. This set is going to be a lot of examples. Alright, so here we have an example of a basic method. So public static void main string bracket bracket args with curly braces. In main, we create A as 6, B as 8. We say int answer, which is a container where we're going to store the result of a method call. The method we are invoking is add. We're sending it A and B. But then when you look at the method add, it receives X and Y, which is very strange because you would think that they should be called A and B. But this is perfectly fine. A and B do not exist down here. I'm trying to show you these are not those variables. What's actually happening is here let's go ahead and pass it this way. Woo! That was a bad drawing. But 6 is being sent. And then we send 8. So when we invoke this method, we pause main. Main cannot move forward until this method completes. So we pass an 8. So then we can say y has a value of 8. X has a value of 6. So when we do int sum equals 6 plus 8, which is 14. I don't know what I'm writing. Let's just mark that out. 1, 4. So 14. So then sum is 14. We are not returning sum. We are returning its value right over to this area. So this gets sent back here. And that's 14 that's being sent to this spot. 14 then gets stored into answer. Then we do system.out.print answer, which contains the value 14. Let's move on to our next example. This one, I'm going to do the same thing. It's almost the exact same example. A is 6, B is 8. So for A, we send it down here. And this is typically how we'd write it. If A were a well-defined variable name like year, we wouldn't come up with some other name that is different down here. We want to have descriptive names. We would still use year. So if you have a descriptive name, if that description works in main, it also works down there. So we shouldn't just arbitrarily come up with new variable names. So A is being sent as 6. It gets stored into a variable named A. Now I want you to note that this A is different than this A. They are two different containers that have the same name because A exists in the method we created it. So there's an A here. When we go down here, this is a different variable A that will exist for this method. B is 8. The next example should explain that further. Then we say the difference is, and we're not adding this time, we're doing subtraction it looks like. So I don't know if I said add earlier, but we're definitely doing subtraction. So A minus B. 6 minus 8 is negative 2. So we get negative 2. Difference is negative 2. We don't return difference, we return its value. So that goes right back to here. We return a negative 2. Answer becomes negative 2. Then we print the answer, which is negative 2. Let's move on to the next example. This next example looks almost the same, but let's work through it. So the reason I made all these examples very similar is so you can see some minute changes. So here A is 6, B is 8. We pass 6 just like we normally do, or just like we did last time. Then we pass 8 just like we normally did. But here, the first value we get, we put it in a container called B. So B down here is 6, and A is 8. That doesn't change these variables. A up here is 6, but this A is 8. They are different containers. I'm trying to drive that point home for you. A lot of people make mistakes on their containers or their passing orders. and you need to realize that it's passing values. It won't reorganize them for you. It doesn't care what they're called. It'll call them whatever you want to call them down here. Because what you really passed was 6 then 8. B becomes 6, A becomes 8. So now it's B is 6. So this is 8 minus 6, which is a positive 2. This code is exactly the same as it was before. We just passed things in a different order. Sorry, we passed them in the same order, but we received them. Well, we passed 2 integers, we received 2 integers. But when it got down here, I chose to receive the value for B first, then the value for A. It doesn't say, oh, they sent A then B, let me reorganize those and put B here and A here. We're not sending A and B. We're sending their numeric values. That's why this is going to kick back an answer of 2 instead of -2. And it appears here, and you're good. Example 4. So here, x is a double. Y is an integer. I try to call an add method. I send x as 9.9. I send y as 11. I call them A and B when they get there. But here's the problem. I send 9.9. 9.9 cannot be put into an integer. I was supposed to send x. I was supposed to send y then x. That way it would be an int then a double. There is no method signature that can match double int, because a double cannot be downgraded to an int in the passing. So if you have decimal places, the computer is going to be like, I don't have a method that receives a double then an int. So it cannot run. So this is going to be a syntax error. It won't even compile. If you had passed it in the other order, it would have run and done something. Well, it would probably be mad that you're returning a double into an int container. So there's other problems. But it wouldn't be mad about invoking the method. Right now, it's like, I can't invoke that method because that method doesn't exist. All right, here's an example of calling a void method. Print man. We want to print out a man. We call print man. It goes here. It works and prints stuff to the console. It prints that. Then on the next line, it prints that. On the next line, it prints this, and maybe he's got some big shoes. Then the method ends. There's nothing left in this method. So the method ends, and we go back to main. There's nothing left in main, and we're done. So you can actually run methods that do not compute and return a result. This method is void. It performs a task for us, but it doesn't have anything it needs to return. By value. So passing by value. So again, right now, everything we do is going to be a by value pass. Even strings will behave like by value. So for this chapter, I don't have a good way to show you by reference until we get further in the year. I just want you to know that there is a difference between by value and by reference. I want you to know if you send something by value, changing it will have no effect on the original. If you send something by reference, changing it will affect the original. But I can't show you a by reference example yet because we do not have anything that is passed by reference where you can see that it changes the original, because the only thing we can pass by reference right now are strings, but they behave like by value. All right, now that I've went through this, let's go ahead and look at this. We've got 6, we got 8, we're doing the add thing again. So we're sending it down here. We're like, hey, I'm going to send a 6. We're like, hey, I got an 8 for you. When you get down here, you're like, oh my, there's a container. A equals 6. I have another container. B, I'm going to set it equal to 8. And then we say, you know what? I really don't like the value of A. Let's change it to 44. Then we do A plus B. 44 plus 8 is 52. So we get 52. And we send 52 back to there. Answer is now 52. When we go up here and we print A, Some of you might be thinking, oh, you print 44. No, we are no longer in this method. The a down here no longer exists. We are in this one. And even though we sent a to the method, it didn't change it because we didn't send a. We sent 6 to the method. It created a second container called a, which we changed. It did not affect the original container. So we get a 6. When we print the answer, though, the answer is 44, not 14, because we changed a. Sorry, I don't know why I said 44. The answer is 52. So we print 6 because that's what our local variable is. But when we ran this method, our calculation for determining the sum used this new value that we made in the method, and that's how we got a 52, because 44 plus 8. All right.